Good day, Sir Rigo Millares. Today, I will discuss based on how we understand on the topic weeks 1 and 2. I am Flordeline Almacen, Group 1. To start our topic, we want to greet you have a very nice day, sir. So, first is the number pattern. Number pattern is a pattern or sequence in a series of numbers. Thus, pattern generally establishes a common relationship between all numbers. For example, 0, 5, 10, 15, 20, 25. Here we get the numbers in the pattern by skip counting 5. Given are the steps to identify a number pattern. To solve the problems of number pattern, we need to first to find the rule being followed in the pattern. To find out the rule, we need to see the first few numbers in the series. Try to see the difference between consecutive numbers. It will help us understand the relationship between the numbers. Example number 1. 11, 17, 23, 29, 35, 41, 47, 53. In this pattern, we see that every term in the sequence has grown or increased by 6, or the difference between any two consecutive numbers is 6. So we can get the next term by adding 6 to previous term. Example number 2. 18, 15, 12, 9, 6, 3. In this number pattern, we can see that every term in the sequence has reduced by 3 or 3 has been subtracted from every number compared to its previous one. So we can subtract 3 from the previous term to get the next term. In the above two examples, the number pattern is formed by a common difference in all its terms. Second is concept of sequence. A sequence. A sequence is a set of values which are in a particular order. In simple words, we can say that a succession of numbers formed according to some definite rule is called a sequence. Mathematically, a sequence is defined as a map whose domain is the set of natural numbers, which may be finite or infinite. In the range may be the set of real numbers or complex numbers. We can represent it as m.n arrow x, where n is the set of naturals. The sequence is finite or infinite depending on whether the set n is finite or infinite. If x is the set of real numbers, then f is said to be real valued sequence, while if the set x is of complex numbers, then f is termed as a sequence of complex numbers. For example, Mary or Mary is a sequence of letters with the letter M first and Y is the last. This sequence from Army also the sequence 1, 2, 3, 1, 1, 2, 3, 5, 8, which contains the number 1 at two different positions, is a valid sequence. Sequences can be finite as in these examples or infinite such as the sequence of all even positive integers 2, 4, 6, ... And another examples of sequences include those made up of rational numbers, real numbers, and complex numbers. The sequence open parenthesis dot 9 dot 99 dot 999.9999 close parenthesis, for instance, approaches the number 1. In fact, every real number can be written as the limit of a sequence of rational numbers, e.g. via its decimal expansion. As another example, r is the limit of the sequence 3, 3.1, 3.14, 3.141, 3.1415 ... which is increasing. Third is common types of progression. There are two types of progression. First is an arithmetic progression and the second is geometric progression. First is a arithmetic progression. Arithmetic progression is a sequence where the differences between every two consecutive terms are the same, and it is a sequence where each term except the first term is obtained by adding a fixed number to its previous term. There is a possibility to derive a formula for the ninth term. For example, the sequence 2, 6, 10, 14 is an arithmetic progression or AP because it follows a pattern where each number is obtained by adding 4 to its previous term. In this sequence, 9 term equals 4n minus 2. The terms of the sequence can be obtained by substituting n equals 1, 2, 3, in the 9th term. And here's the other examples. When n equals 1, 4n minus 2 equals 4, 1 minus 2 equals 4 minus 2 equals 2. When n equals 2, 4n minus 2 equals 4, 2 minus 2 equals 8, minus 2 equals 6. When n equals 3, 4n minus 2, therefore 4, 3 minus 2 equals 12 minus 2 equals 10. But how do we find the 9th term of a given sequence? Let us learn about arithmetic progression in this article with solved example. And here's the examples number 1. Find the general term of the arithmetic progression. Negative 3, negative 1 half 2, And this is a solution. The given sequence is negative 3, 1, 3, 2, Here, the first term is a equals negative 3 and the common difference is d equals negative 1 half negative 3. Therefore, the answer is negative 1 half plus 3 equals 5, 2. The general term of an arithmetic progression is calculated by the formula like this. The geometric progression. A geometric progression is a sequence where every term bears a constant ratio to its preceding term. Geometric progression is a special type of sequence. In order to get the next term in the geometric progression, we have to multiply with a fixed term known as the common ratio every time, and if we want to find the preceding term in the sequence, we just have to divide the term with the same common ratio. Here is an example of a geometric progression is 2, 4, 8, 16, 32, having a common ratio of 2. The geometric progressions can be a finite series or an infinite series. The common ratio of a geometric progression can be a negative or a positive integer. Here we shall learn more about the geometric progression formulas and the different types of geometric progression. For the examples, question number 1. In a certain culture, the count of bacteria gets doubled after every hour. There were 3 bacteria in the culture initially. What would be the total count of bacteria at the end of the 6th hour? And here the solution. Here, the number of bacteria forms a geometric progression where the first term A is 3 and the common ratio R is 2. So the total number of bacteria at the end of the 6th hour will be the sum of the first 6 terms of this progression given by S6. S6 equals 3, 2, 6 minus 1, 2 minus 1. 3, 64 minus 1, 1. Therefore, 3 times 63 equals 189. So the answer is the total count of bacteria at the end of the 6th hour will be 189. In the formula for the 9th term of the geometric progression is like this, where A is the first term, R is the common ratio, N is the number of the term which we want to find. And here's another example of 9th term of an arithmetic progression. In general, the 9th term of an arithmetic progression with first term A and common difference D is A plus N minus D. So where the sequence 3, 5, 7, 9 UN equals 3 plus 2 N minus 1 equals 2 N plus 1, which we already knew. The sum 2 N terms of an arithmetic progression, and this is given by like this. You may need to be able to prove this formula. It is derived as follows. The sum 2 n terms is given by Sn equals a plus open parenthesis a plus d plus open parenthesis a plus 2d close parenthesis plus 3 dots plus open parenthesis a plus open parenthesis, n minus 1, close parenthesis d, close parenthesis 1. If we write this out backwards, we get Sn equals a plus n minus 1d plus a plus n minus 2d plus 3 dots plus a2. Now let's add 1 and 2. 2Sn equals 2a plus n minus 1d plus 2a plus n minus 1d plus 3 dots plus 2a plus n 1d. So the answer is like this. And another example of arithmetic progression. Sum the first 20 terms of the sequence 1, 3, 5, i.e. the first 20 odd numbers. And the solution like this. And 10 times 40 equals 400 is the answer. And another examples of 10 terms of arithmetic progression. Find the 10th term of the AP 2712. The answer is the given AP is 2712. Common difference D equals 5. The first term is A equals 2. Hence, 10th term is A plus 9D equals 2 plus 45. And the answer is 47.